Hello, my name is Ajax Alexis Casarrubia Rodriguez, and I'll be talking about lightnings. Well, lightnings. There are different classes of lightnings. These are cloud to ground and cloud discharges, like here in the image we can see. Uh, this is the cloud to ground, and these other ones are the cloud discharges. About 19% of or more of global cloud to ground lightnings are considered negative downward lightnings. It's called this way because, on one hand, negative charge is transported from the cloud of the ground, and on the other hand, this this process begins in the cloud and then goes downwards. Um, Other types of cloud-to-ground lightnings include positive downwards, negative upwards, and positive upward discharges. The only difference between all of these is either the charge or the direction of the lightning. Uh, but there are also bipolar lightning discharges, which can transfer uh, which transfer to ground both positive and negative charges. Something to take into consideration is that cloud to ground discharges constitute only about like 25% of global lightning activity, and about the other 75% do not involve the ground at all. Like in this image, we can see that these other ones are the cloud discharges, and there are different types. The intra-cloud that happens within the cloud, the cloud to cloud, and the cloud to air. Uh, well, inside the cloud, what happens inside the cloud? What happens inside a cloud for a lightning strike to occur is the polarization of positive and negative charges between a storm cloud. Here in this image, we can see two different situations. In here, we can see a negative downward flash. In here, the positive charge is at the top of the cloud and the negative charge is at the bottom. Usually the top is known to acquire an excess of positive charge, like in the image, and at the bottom of the storm cloud, uh, there's usually an excess of negative charge. This can happen because, as we know, clouds contain water and ice particles moving within it. But also there's a continuous stream of water vapor, as I can say it that way, that goes from the earth to the clouds. Uh, but as it approaches the cloud, this evaporated water start to form droplets of water, and when it actually reaches the cloud, it usually collides with the water droplets inside the cloud, and within these collisions, electrons are released, and well, more than released, they are ripped off the droplets, causing a separation of negative electrons. There's also the cloud's electric field. This electric field surrounds the space around the cloud, like we can see here, and also interacts with the Earth. Electrons on the surface of the Earth are repelled by the negative charge of the electric field of the bottom of the that is located at the bottom of the cloud. Oh, sorry. Uh, in this image, we can see that there's an arrow in both situations pointing downwards, and it's called leader. The leader, or also called first stroke, creates a path between the negative cloud charge region and the ground. This will the bottom in this image. The bottom part of the cloud will be the charge region, and this leader, as it's called, distributes negative charge from the cloud along the path. Like we can see here, it's distributing the negative charge of the cloud as it goes downwards. Then there's also a return stroke. This return stroke returns, as his name says, through the same path of the leader, moving from the ground towards the cloud. This means upwards, and neutralizes the negative leader charge. But at the end, both leader and return stroke charge effectively effectively transport negative charge from the cloud to the ground. Well, let's continue with the electric field. As the static charge in the cloud increases, the electric field around the cloud will also become stronger. This same electric field is capable of ionizing the surroundings of the cloud, and the molecules that compose the air are transformed to conductive plasma. This, this process of transforming the surroundings, the surrounding air of the cloud into conductive plasma, is what allows the charge transfer. Lightning bolt. How I mentioned earlier, the lightning bolt begins with the development of a first stroke, or also called leader. The reason of the passing of the stroke is not well known, because it's kind of random. Even if it's the first stroke, it's not actually the lightning bolt, as it only serves as a path between the cloud and the earth. Because of the repulsive force of electrons experienced at the Earth's surface, as the first stroke approaches the Earth, the electric charge in the surface in the surface of the Earth will increase. This causes the positive charge to be attracted upwards, and also the negative charge in the Earth will be repelled and will be going downwards in the Earth. But as I was saying, here in this image we can see the leader and the upwards, or it's also called upwards leader. This is a positive charge from the Earth that is going towards the leader going downwards. When the two meet each other is when the actual lightning is formed. But because of how fast this process is, the high current return stroke rapidly hits the path to a peak temperature near 30,000 degrees Celsius. This results in a violent expansion, and is what actually creates the shockwave, or how we also know it, the thunder. The current and the lightning. Well, uh, the impulsive component of the current in a return stroke is often followed by a continuing current, which has a magnitude of 10 of hundreds of amperes. This continuing current is caused because charge flows continuously over a longer period of time through the lightning channel. It's basically the longer the flash flash the longer the flash is. Continuing current with a duration of in excess of 40 milliseconds are known as long continuing current, and between 30 and 50% of all negative cloud to ground flashes contain long continuing current. This continuing current can also be dangerous because it can start fires, for example, of the amount of heat it produces and energy that transports. Well, it's kind of the same. But one of the reasons lightnings are dangerous is because it's hard to know where and when will they strike, or or how the lightning will actually behave. Also, the average lightning carries around 30,000 amperes of charge, which of course will also result in a very high temperature and voltage. Even being around in an area struck by lightning can affect you severely because of the ground current and also the difference in voltage. Like for example, like in this image, we can see the even if the lightning hits the tree, the ground current will also affect the surroundings. Mm, that's basically all. Here are my references that I use to get information. Thank you very much for your attention.